Dear students, in previous part 1, we have learned about the polynomial. What are the polynomials, their classification, their types. Now we will learn something different. Something different means we will learn about the relationship between the zeros and the coefficient. Before that, what are the zeros? In ninth class, we have already learned zeros. Zeros means zeros of polynomial means the value of variable which make the polynomial zero, right? We have two type of equation, one is linear and quadratic basically, right? I'm just taking an example of the linear equation. Here we are going to learn relationship. Relationship between zeros and the coefficient of a polynomial, right? We have one linear equation. First part is we have linear equation. As we know, linear means power 1 or degree 1. Degree 1 means it has one solution only, one solution, or having one zero only, right? Like in standard form we have equation. In standard form we have equation ax plus b. Ax plus b, if we want to find the zero of this polynomial, we will have to take 0 is equal to 0 equal to this polynomial, and according to this we can say x will be equal to, by solving, minus b upon a. This is the zero of polynomial. If we are taking an example, suppose 3x plus 2 is a polynomial, we will have to take 0 if we want to get 0 of the same. So this will be equal to here x will be equal to x equal, by transposing, minus 2 upon 3. We will take, according to this, x is equal to minus b upon a, and here b is 2, a is 3. It means we can say the minus sign as it is, we are taking b is 2, so plus 2 we will write here, upon a means 3. This is equal to minus 2 upon 3. Means we can say that 0 of linear equation x equal minus b upon a. Second part is relationship between zeros and coefficient of quadratic equation. Second one, quadratic equation, right? In quadratic equation I am taking an example. Standard form, you know, as we have learned in 9th class also, standard form is ax square plus bx plus c, right? We are going to take an example for the same. I am taking an example of a polynomial. Suppose polynomial is 3x square minus 9x plus 6. We want to get 0 of the same, so we will take is equal to 0, right? It is equal to 0. Now we have to solve. We can use splitting method here. So this will be equal to 3x square minus 3x minus 6x plus 6 is equal to 0. So here 3 and x common, left x minus 1 minus 6 common, x minus 1. So here we have x minus 1 and 3x minus 6 is equal to 0. One by one we will take. First, x is equal to 1 from this, and from this x is equal to 6 upon 3 means 2 will come. So this implies x will be equal to 2. Here we have two zeros. One zero is x equal 1 and other 0 is x equal 2. We have already learned in 9th class, if we will put this value in the given polynomial, this will become 0. Okay, now see by these what we observe. If we will take sum of 0, sum of 0 is 1 plus 2. 1 plus 2 is equal to 3. we can see here this is equal to minus 9 upon 3. Minus 9 upon 3 means this is ax square plus bx plus c. From here you can see this is b minus 9, this is a, and the minus sign is from here minus b upon a. It means this will be equal to 3 is 9. So we can write it, this is coefficient, minus sign as it is, coefficient of x divided by coefficient of x square. Similarly, now second one we will do product of zeros. Product of zeros, how to multiply? One zero is 1, other one is 2. So 1 multiplied by 2 is equal to 2. This will be equal to 6 upon 3. Now see here, what is 6? Here c. This is c and 3 is a upon a. We can say coefficient of, not coefficient of x, this is constant, right? Constant term upon coefficient of x square, right? This one, constant term upon coefficient of x square. Now we will try to prove this one, right? We have two relations and these two relations are true for all the quadratic equation. Any equation you may take, this will be true for all. Now see for second one. I'm just taking new page now. Means now we want to prove if alpha and beta are zeros of a quadratic polynomial. Here we found a 0, x equal 1 and y equal 2. Suppose the name of these zeros are alpha and beta. So if alpha and beta are two zeros of quadratic equation, right, or polynomial, that is ax square plus bx plus c, right? So we have to prove that alpha plus beta means 2 0, sum of 2 0 is equal to minus b upon a, and alpha beta means product of 0, what we have done just before, will be equal to c upon a. Let's prove this one. And prove, since alpha and beta are 0 to the quadratic polynomial, let's write this one. Since alpha and beta are zeros of quadratic equation or polynomial, ax square plus bx plus c, as we have learned in 9th class. So x minus alpha and x minus beta will be factor of polynomial, right? Is it or not? This will be factor of polynomial. So we will compare with the standard form. See, ax square plus bx plus c will be equal to k. K we are taking as a constant, x minus alpha and x minus beta. Product of these two will multiply by k should be equal to this one, because this is the same equation. So this will be equal to again ax square plus bx plus c will be equal to, let's multiply this one, k x into x square minus alpha x into alpha minus x into beta, and minus minus plus, this is alpha beta. So we can say ax square plus bx plus c will be equal to kx square minus sign alpha plus beta, we can take common, x plus alpha beta. Here also k minus k sign here also will come, and here also k will come. I'm just taking k here. Okay, this one, if we compare this work also we have done in previous class. Compare the a b c, right? A b c. When we will compare with this one, what will come? A is equal to k, right? B is equal to minus k alpha plus beta, this one, and C is equal to k alpha and beta, right? Now putting this value of putting k equal a in second, this one we will put this value in other two and we will find the value. See, putting k equal a, this is first relation, this is second relation, and this is third relation. So k equal a from relation 1 to relation 2 and 3, right? From 2 what will come? If we will put k equal a here, b will be equal to minus a alpha plus beta. So alpha plus beta by dividing, what will come? It imply alpha plus beta will be equal to minus b upon a. You can see this is same as what we have written before, right? Alpha plus beta is equal to b upon a. Second thing, from second relation, from here this is c is equal to a alpha beta. So from here it imply alpha beta is equal to c upon a. This is second relation of the same, right? This is the relation between the coefficient. Now you can see this b upon a. B upon a, what is b? B is coefficient. See, this is b upon a. What is b here? B is coefficient of x. You can see in this one, coefficient of x. So coefficient of x and x square. So we can write is equal to, with minus sign, coefficient of x divided by a. A is coefficient of x square. Similarly here also we can write this c. What is c here? C is constant term. So this will be equal to constant term upon a is coefficient of x square, right? So this was the proof. We can say, so sum of zeros will be equal to minus b upon a and product of zeros will be c upon a. Now we will use in chapters. Okay. Now see, let's see some graphs. In last video we have learned about the polynomial that it's depend on the degree. The value of variable is equal to, is supposed to, suppose zeros are 2, it means that is quadratic equation. Is 3, it means that is cubic equation. Is 1, it means linear equation. So by graph can we identify it is 1, 2 or 3. Let's see from one book. We have, say this one, we have some graphs here, right? In this one, see, this one is a linear graph. Why? Because this is a straight line. This one is also a linear graph. This is a straight line. This one a parabola. So this is a quadratic equation. This is also a parabola. This is a quadratic equation. But this is neither straight line nor parabola. So it may be a cubic equation. Similarly here also, this is also neither a straight line nor a quadratic equation, right? Neither a straight line nor a parabola. This is also a maybe a cubic equation, right? Let's see. Now we will do 2.1 of our book. This is 2.1, exercise 2.1 of our book, right? Let us see. I'm just trying to showing here. See, 2.1. Examine by seeing the graph of the polynomial with the given below whether they are linear or quadratic polynomial or neither linear or quadratic polynomial. See, this is a line. So this is linear equation. This is a straight line. So this will be a linear equation. This is a parabola, right? So this will be quadratic equation. This is a parabola open on the top. This is also will be a quadratic equation. The same just before we have done. This one neither a straight line nor a parabola. So this is neither a quadratic equation nor a linear equation. Here also same. Just try to do from your book. And in next video we will try to learn next thing. Please try to finish 2.1. If there is any problem, ask to me. We will do next thing. Thank you. And please, if you did not subscribe the channel, subscribe, share and like, so that you can get notification, and ring the bell also so that you can get notification for the next video. Thank you.